viewers, in my previous lecture I had discussed glycosphingolipids, which belong to the subclass sphingolipids. The term sphingolipids is used to designate lipids derived from alcohol sphingosine. In glycosphingolipids, either a monosaccharide or an oligosaccharide is directly attached to the ceramide by an O-glycosidic bond. The sugar units function as a polar head. So as you can see on your screens now, you can see the structure of a glycolipid, in which we can see that this glycolipid is made up of three parts. First is the backbone, which is the alcohol sphingosine. Second is the fatty acid unit, and the third is the sugar moiety. And this sugar moiety is the polar head of the glycolipid, and sphingosine unit along with the fatty acid forms the ceramide. So in summary, we can say that a glycolipid is made up of sphingosine, a fatty acid, and a carbohydrate unit, which may be a monosaccharide, oligosaccharide, or a derived carbohydrate. This is what you have to remember. So all glycosphingolipids have ceramide linked with one or more sugar residues or their derivatives. So before we proceed further, let us see what is ceramide. A ceramide is formed when a sphingosine is linked to a fatty acid by an amide linkage. So this is our sphingosine. That is, here we had CHOH, and this CHOH reacted with a long chain with a fatty acid, resulting in an amide bond here. So what is a ceramide? A ceramide is formed when sphingosine is linked to a fatty acid by an amide linkage. When we talk of glycolipids, what we find that this hydrogen, which is attached to the hydroxyl group on the first carbon, is replaced by a carbohydrate unit, which may be a monosaccharide, oligosaccharide, or a derived carbohydrate. We get a glycolipid. So now we've seen that means the glycolipids that can be classified into sphingoglycolipids. And as I told you in my last lecture, that on the basis of the alcohol which is present in glycolipids, we can classify them into two. One is glyceroglycolipids, in which the backbone is the glycerol molecule, whereas in sphingoglycolipids, as we've seen just now, the backbone base is the sphingosine. So on the basis of the alcohol, glycolipids can be classified or divided into two, which are glyceroglycolipids and sphingoglycolipids. Now sphingoglycolipids can be further classified into four classes depending on the number and type of carbohydrate moieties and their derivatives linked to sphingosine backbone. So as you can see on your screens now, again I have shown you the basic structure, in which we have a sphingosine, long chain of fatty acid, and then we have a sugar molecule attached here by beta linkage. So generally what you have to remember is that in a glycolipid, especially the sphingoglycolipid, you will have a sphingosine backbone, a fatty acid, and you will have a polar head, which may be a monosaccharide, oligosaccharide, or a derived carbohydrate. So on the basis of what is the sugar unit present in sphingolipids, we can classify glycosphingolipids into 4 classes. First are cerebrosides, then we have globosides, gangliosides and sulfatides. These can be further subdivided into 2 classes. First is neutral glycosphingolipids and the second one is acidic glycosphingolipids. When we talk of neutral glycosphingolipids, we have to remember that these will be neutral at pH 7, whereas acidic glycosphingolipids will not be neutral at the pH 7. And to these categories, what we have now is that if we think of cerebrosides or globosides, these are neutral glycosphingolipids, whereas sulfatides and gangliosides are acidic sphingoglycolipids because they have acidic groups in them. Sulfatides have sulfate group in them and gangliosides have sialic acid in them, which gives them the acidic character. We have no such groups in cerebrosides or globosides. Whereas when we discuss sulfatides with you, you will find that sulfatides are derivatives of cerebrosides in which sulfate group is present at one of the hydroxyl groups of the basic galactocerebroside. So now let us discuss these neutral glycosphingolipids in detail. The first example or the first category of this group is cerebrosides. And cerebrosides are the simplest glycosphingolipids with a single sugar linked to a ceramide. And as I've already said, cerebrosides are neutral glycolipids. How are they formed? They are formed by joining of a monosaccharide connected directly to the OH at the C1 of the ceramide moiety of the glycosidic bond. So what do we find here? That this is your ceramide. When I talk of ceramide, we are talking of this unit, and now this is attached to a glucose or a galactose unit. So depending upon which unit is present in a cerebroside, we will call them as glucocerebrosides or galactocerebrosides. So a glucocerebroside is the one in which the sugar is glucose, and this is present in liver, spleen and RBCs. Whereas in galactocerebroside, the sugar unit is galactose, and these are present in central nervous system. According to the IUPAC, IUBMB, the term cerebroside is a trivial name, because when we say that it is a cerebroside, we are not able to tell you whether it is a galactose cerebroside or it is a glucosyl cerebroside. So for that, and you know what are the full forms are of IUPAC is International Union of Pure and Applied Chemistry, and IUBMB is International Union of Biochemistry and Molecular Biology. So these two unions, the people involved with this, they did not agree to the word cerebroside as the IUPAC name. So they said this is the trivial name which we can use every day, but when we have to specify, we will say it is either galceramide or glyceramide. This is the abbreviation. So how do you now name these cerebrosides according to IUPAC, IUBMB naming? They will be named on the basis of the sugar molecule which is present in this cerebroside. If the sugar molecule is galactose, it will be named as galactosyl ceramide, and the abbreviation would be capital GAL, capital CER, which indicates that the sugar unit here is galactose, which is linked to ceramide. And when we talk of glucosyl ceramide, what are we indicating here? That is, the glucose unit is attached to ceramide through O-glycosidic linkage. And the abbreviation here is capital G, LC, capital C, ER. So as you can now again see on your screens, the structure of ceramide plus galactose, which is equal to galactoceramide or galactosylceramide. So what do you observe in this? That this part, this till here, is the ceramide, and here the anomeric carbon of the monosaccharide, which is galactose, is involved in beta linkage with the OH group on the first carbon of the alcohol moiety, which is your sphingosine, resulting in the formation of galactosylceramide. Now we know further that when we are talking of galactosylceramide, and we know this is found in brain. So the 4 types of cerebrosides have been isolated from the cerebrum, which is the grey matter of the brain and the myelin sheath. Now all the cerebrosides are characterized by presence of fatty acids which have 24 carbons in it. For example, we have cerebronic acid, which is also known as alpha hydroxy lignoceric acid, lignoceric acid, nervonic acid, or oxynervonic acid. We discussed that cerebroside is a trivial name, and behind cerebroside behind the term cerebroside tree is very interesting. J.L.W. Thudicham coined the term cerebrosides for a group of glycosidic substances found in brain, and he said that it was composed of 3 building blocks: a fatty acid, a long chain base, and a hexose. He did not say that the long chain base was sphingosine. He just said a long chain base. Thudicham, 1874, isolated cerebrosides as an impure fraction consisting of 2 principal species, which were phrenosine and kerosene, that differed structurally by their fatty acid component. That is, point to be noted here is that in these cerebrosides, the backbone base was same, the carbohydrate which was present there, that the monosaccharide was same. They only differed into what was the fatty acid which was present in them. And these 2 species also differed physically in their optical activity. That is, phrenosine was found to be dextrorotatory and kerosene was found to be levorotatory. And you know, when we say dextrorotatory, what we mean by this term? It means that this molecule was able to rotate the path of plane polarized light in right hand direction, whereas kerosene, which was levorotatory, rotates the path of plane polarized light in left hand direction. So Thudicham called the sugar chain obtained by hydrolysis of crude product as cerebrose. Many years later, Thierfelder showed that phrenosine contains a long chain alpha hydroxy fatty acid and that the acid of kerosene is lignoceric acid. He also identified that the sugar component as galactose. So Thierfelder, many years later, showed that the acid component in kerosene and phrenosine was different, but the galactose was the same, and he was also able to identify that kerosene had alpha hydroxy fatty acid, whereas phrenosine had alpha hydroxy fatty acid, whereas kerosene had lignoceric acid. But remember, yet the structure of the 3rd building block, the long chain base, remained elusive. its structure could not be elucidated. Since it was a mystery, like the enigma of the Greek Sphinx, Thuricham called this component as sphingosine. The correct structure of the long chain base was finally established by Cartel et al. In 1947, who also introduced the term sphingolipids to designate lipids derived from the parent base sphingosine. Now the structure of cerebrosides was clear, that is, it is made up of a base which is sphingosine. It has a long chain fatty acid, and these long chain fatty acids will have 24 carbon atoms in it, and the sugar present in them is the galactose sugar. Now we go on to how these cerebrosides were further classified into 4 types on the basis of the acids present in them. So what we've seen, that galactocerebroside has been classified on the basis of the sphingosine molecule as well as the galactose sugar which is present in them. So what we'll find that in kerosene, cerebron, nervon and oxynervon, in all of these 4, the base is same, which is sphingosine. The carbohydrate, that is the monosaccharide, is same, which is galactose. Where do they differ? They differ in the structure of the fatty acid which is present in them. So kerosene has gal, ser, dash NFA. What does this indicate? The NFA here indicates that the acid present in them, the fatty acid present in kerosene, does not have a hydroxyl group. It is a simple lignoceric acid which has 24 carbons in it, and it is a saturated acid. There is no branch in it. So if you look into the structure of kerosene, what do you find? That this is the long chain unsaturated sphingosine, and to the first OH of the sphingosine, galactose is attached. Where does it differ from all other 3 other cerebrosides? It is here where we have the carboxylic acid which is involved in amide linkage. Please remember, it is kerosene, Kerasine, and not kerosene, Kerosene. Kerosene is a fraction which is obtained by fractional distillation of petroleum, and it is a fossil fuel which we use for burning atom, that is kerosene, and this is kerosene. Kerosene is a glycolipid which is a cerebroside. So this is the lignoceric acid which is present in kerosene, and it is also known as tetracosanic acid. When we say tetracosanoic acid, what do we mean by here is cosanoic or cosane indicates that it has 20 carbons in it. And when we say tetra, that means 20 plus 4 becomes 24. Tetracosanoic, oic is for S, indicating that this is a carboxylic acid. So the lignoceric acid is a simple fatty acid. It is not unsaturated, it is a saturated acid, and it does not have a hydroxyl group in it. Now when we talk of cerebron, which is also known as phrenosine, it is gal ser HFA. What indicates here is that it has a hydroxy fatty acid in it. Rest of the composition is same as kerosene. So what we have here is we have a hydroxyl group here in the fatty acid. So if you look into the structure of cerebronic acid, what you find at the second position, where we start numbering from here, 1, 2 and then so on, we have a hydroxyl group at the second position of the lignoceric acid. So this is also known as alpha hydroxy lignoceric acid. The next cerebroside is Nervon. How does Nervon differ from the other two? It has an unsaturated lignoceric acid, and we have unsaturation at C15, as you can see on your screens here. The double bond is between C15 and C16. This is your 13 carbon, 1 carbon, and 13 carbons, your 14. This is the 15th carbon, and here we have a double bond. So the basic structure is that of lignoceric acid, which is a 24 carbon acids. It may be saturated, it is saturated, and then we have the acids like alpha hydroxy lignoceric acid, which has a hydroxyl group. We have a nervonic acid, which is unsaturated lignoceric acid, in which we have a double bond at the 15th carbon. Now, last one is the oxynervon. An oxynervon contains oxynervonic acid. That is, in this group, we have 2-hydroxynervonic acid. That is, the hydroxyl group here is at the second position, and we have a double bond at the 15th carbon. So this is the difference here. So we in brain we have 4 cerebrosides, which are Nervon, ferrison, and kerosene. For this lecture, I had referred to the books by Morrison and Boyd, Claydon, and in my next lecture, now we shall be discussing globosides. Thank you.